Remember, guys, I told you, this class is hard. It's not for everyone. See, in person is hard. Online is harder. Okay, so now it's not for everyone. So I understand. You try to evaluate your situation, and you continue or no. It's up to you. Okay, so now we start second chapter. Easy, in my opinion. Que is about the linear system of equation, no? And we study today in 2 dimensions. After we study in 3 dimensions. So let me start recording or recall 2 dimensions. That's pretty easy. This is intermediate algebra. Now, after I want to complicate more in 3D. Okay, so now remember we have 2 methods for solving linear system of equations. This is universal. We have one method that's called substitution. Another method is called elimination. You use it either way, doesn't matter. However, it's easier solving the system using substitution when the coefficient in at least one variable is 1 or negative, because you avoid fraction. However, elimination, no. Elimination is universal, and this is, in my opinion, is the best method that we use. And we use substitution only in one particular example in which the coefficient is 1 or negative 1. The coefficient is in front of the variable, I try to say. So you see that the equation number 2, look at that. Okay, and this system, I want to call always 1, 2, a number of the equation, because we study complicated problem in which you have several equations, no? So equation 1, equation 2, equation 3, equation 4, equation 5, but not today. So I seek in the equation 2, well, the coefficient from the variable x is 1, or the coefficient from the y is negative 1, and also in the equation 1 happen exactly the same, not exactly, but similar. Okay, the coefficient is 1. So I take advantage of this one, no? So now you take the equation 2, in my opinion, is the easier equation. And you, for example, make a decision to isolate the x. Okay. You put x equals 4 plus y. Because I move the y, it's located in the left-hand side to the right-hand side like a positive. Now I take this expression and substitution, this is the name of the method, substitute it into the x value, but in another equation, not in the same. Use substitution in the same, no, you never get solution, you never get nothing. However, so you substitute in the second, in the first one, yeah, you get solution. So I copy now. I copy. No x anymore. No. I copy. 4 plus y, que es equivalent. Plus 2y equals 7. Oh, so in that moment, we have one equation that contains only one unknown. Entonces this is pretty easy to determine the y value. No, you combine that term. This is 3y, 1 plus 2 is 3. The solve for y, 3y is equal to 7 minus 4. Okay, by coincidence, is 3 also. Divided by 3 both sides. And so because y value is 1. Y value is 1. I feel no, because the idea is find the ordered pair to represent the solution of this. Therefore, to finish that, use substitution y equal 1 in either equation, in the equation 1 original, in the equation 2 original, or in my opinion, the best way is equivalent in this equation. Because x is isolated, waiting for me. X is equal 4 plus 1, because I know that the value for the y in the solution is 1, therefore x is 5. Therefore, the solution is the ordered pair 5, 1, que one interpretation geometric interpretation for this idea is, so you, for example, open Desmos and you type in each equation one by one because it's 2D and Desmos is 2D. In one dimension, it's impossible using Desmos. It's possible using another software, but you don't care too much for the 3D geometrically because it's too complicated. This is calculus 3. Now in pre-calculus, we need only graphic in 2D. But I want to illustrate the interpretation in 3D, but you don't care about this. Okay, so the solution is the intersection because we have two lines. Line 1, que es the line que es green color, ¿no? Que represent equation 2, I suppose. A line 2, que es the blue, que represent the equation 1. In this case, I suppose, yeah, it's the order, yeah. And the common point, que es the intersection, is the solution. Super, super easy. Everyone understand very well this example? Yes or no?
Yes.
Huh? No question?
Yeah, I understand.
Cool. No. Let's move on to the second example.
Professor.
I don't hear very well, mister.
Makes the lines go in a certain direction.
Say again?
What makes the lines go in a certain direction?
Well, this is the, intermediate algebra in which you plot the line. Do you want to explain this or no?
And yeah.
Well, but this is the intermediate algebra. I teach you this in MIT 1033, kindergarten algebra. No. Go to the lab. I explain this. Pero here no. I suppose you know that. Okay. Okay, let's move on to the second example. Okay, it's a little bit weird. Look at that. We have two equations again. Two unknown. I want to copy ax minus 2y equal to, this is the equation I want to call number 1, it's an A, and 4x minus y equals 5, equation 2. This is my system. Okay, I put it in the curly bracket because this indicates us that these two equations belong to the one system, que es the combination of equations, ¿no? Entonces now my question is now, we can apply substitution one more time or no? Yes or no? Substitution is good or no? Not good. Remember what is the idea for the substitution? Substitution is good when you find or you have coefficient 1 or negative 1 and at least one variable in either equation. What do you think? Yes or no? I don't hear. I hear noise. Do you understand my question or no? No.
Are you asking if we should use substitution or elimination?
Mr. Petty, what your credential is not Mr. Petty. You are guest user. You need to fix that because I take attendance for this. Okay. Everyone have a name. You have no name. It's guest user is because you get in. It's your first time. I know it's not first time. I saw you.
I don't know why. I don't know why it's doing
that. Investigate. I don't want to teach you now. Okay, look. The question, the answer for my question is substitution is good again because I saw in the second equation coefficient -1. Do you see this detail? -1? Do you see or no? Do you see my
Yeah.
whiteboard or no?
Yes.
Yes.
Yes, okay, cool. Now this one is a clue que indicate me que is good. Apply elimination and you take the equation number 2 and solve for y. Entonces, 4x minus y equal 5. I manipulate like that. 4x stay minus 5 equal y. It's equivalent, no? And this is my, so you isolate, solve for y. You solve for y. Now, I take this expression and substitute it where? In the y place. Where? Here, in the another equation. Not in the same, in another equation. Let's copy now. Ax minus 2, pero no y anymore. No, parentheses 4x minus 5. It's important, very extremely important, this parenthesis, because y is only one variable. However, we replace by one binomial. So these two in front multiply everything. Eso porque it's obvious, right? Equal to. I copied the second equation. The only thing I did was substitute y in the first equation by the expression equivalent for x minus 5. Now the rest is baby algebra. You apply distributive property. Ax minus 2 times 4 is 8, and negative 2 and negative 5 together is positive 10 equal to, wow, but something we are happy. And something we are happy is, I saw a positive 8 and negative 8, wow, it's canceled, it's 0. I try to do my best, however, I cannot solving x. If I get one statement, it's completely false. So what is the interpretation there? Well, I try to do my best. However, we have no answer. It's because the system has no solution. No solution. And this situation happens, guys, when the lines are parallel and never touch and never cross. We have no common point because remember the common point is the solution. Do you understand more clear now? Say something.
Yes, it's clear.
Super. What your name is? Shane, no, but it's a woman. It's important when you speak, when you activate the microphone, I see your face in the whiteboard. But it's okay. Does everything follow me? Everyone follow me? No? Yes, Giselle. Okay, but I bring another problem. Because I want to make conclusions. Make conclusions. For example, that example I want to copy one, recopy again, is 3x minus y equal minus 2. This is the equation number 1. And also 6x minus 2y equal negative 4. Okay, cool. I suppose it's similar. System contains two equations and contains two variables, x and y. Two equations, two variables, 2. Okay. Now I try to apply substitution one more time. Oh no, what do you think? We can use a substitution or no? Remember, substitution, yeah, you say, yeah, why, you sell? Because? Yeah, you said say yes. I complement the question with the why. What is the reason? Because negative 1, exactly. She saw that negative 1 here. If you take the equation 1, I copy one more time. I dedicate my time to solve for y. So I 3x, for example, I bring down plus 2, I move to the left, equal 1. Wow, excellent. So I isolate, okay, coefficient negative 1. Very well, Giselle. Now, I take this expression and you replace this y in another equation. Okay, by the way, see, I using the equation 1 at the beginning, I replace in the equation 2 here in the y place. Now we have 6x minus 2 parentheses. Don't forget the parentheses. 3x plus 2 is equal negative 4. Okay, this is easy. This is an intermediate algebra. This is piece okay for us. You apply distributive property one more time. This is 6x minus 6x minus 4 because negative 2 times positive 2 and negative 4. One more time happened something weird. Okay, I tried to do my best, however, it was impossible. Isolate the x because the x is cancelled, it's 0. But this is different because you take negative 4 equal negative 4, it's true state. So what is the interpretation this? Pay attention, it's complicated to understand now. When you cannot solve the variable, however, we get totally false statement, es obvio que no solution, it's a parallel line. But in this case, no. You try to solve it, you cannot. However, you get true statement. What is the interpretation this? Well, the interpretation, guys, is because this equation represents the same line. I try to do the graph of the line, and this, you see only one line. Why only one line, Professor? Because it's the same line. I want to prove, but I want to prove in two different ways. I want to prove. For example, so you take the first equation again. I want to investigate what is the solution. Do you have solution or no? I copy the first equation. Yeah, I solve for y. Let me try. Well, I did that actually. 3x plus 2 equal 1. Okay. This is my another version of the equation 1, but this is a standard form. This is detailed, important, but it's not important now. Is when you write the equation like that, ax plus by equals c. So we have in the left hand side, you have the variable x and y. This is the typical format in the linear system of equation. You put a variable in the left, and in the right hand side you have just a number. In the right hand side you have just a number. In this case was negative 2 or negative 4. Let's take it now the second equation. If we are doing exactly the same thing, I try to solve for y. So basically, I want to express it in slope in a set. In a set form. Negative 4. Okay, let me try to do my best. 6x, bring down, plus 4 equal to y. Oh, divided by 2 because I want y alone. Isolate y. 6 divided by 2 is 3x. And 4 divided by 2 is 2. And 2 divided by 2 is 1. So we get this. And when you compare this equation and this equation, it's the same line. It's the same line. This system can have that characteristic is because the equations are depending. Don't worry too much for the name, because after I want to summarize the idea. Depending. Why depending? So there are equations that are depending and there are equations that are independent. How do you know that? Well, one easy way to understand this is, look, I want to copy one more time this equation that's given at the beginning. 3x minus y equal minus 2, equation 1, and 6x minus 2y equal negative 4, equation 2. This is my system that's given in the test, in the homework online, whatever. If you multiply, let me introduce this new idea. If you multiply the equation number 1, the entire equation number 1, if you multiply, look, and the notation that we use in this guy is, you put a box here, and you put multiplication, I don't know if it's cross or period, doesn't matter, and you multiply by 2. If you multiply the entire equation 1 by 2, 1 by 1, of course you multiply 2 times 3 gets 6. the x is the same. 2 times negative 1 is negative 2y equal and negative 2 and positive 2, sorry, because the multiplier is positive 2 times negative 2 is negative 4. Wow! And you get identical equation number 2. That means, in this case, super easy to see. But I promise, okay, one example is not too easy to see because mixing every new situation, negative number, positive number, fraction number, decimal number, you don't see. But don't worry, because I want to explain every method and technique to discover this idea. The most important thing I want to transmit now is that we have the possibility that we have infinity many solutions. Infinity. So the answer for this example 3 is infinity many solutions. Oh, it's obvious, right? It's obvious, but infinity many solution is completely the R2 plane. So, the plane? No, because this point is no solution. This point is no solution. This point is no solution. Only a solution, the point on the line. This is okay. This is okay. This is okay. This is okay. Why do you choose? I choose multiplication by 2 because I want to prove that the equation 1 and equation 2 are the same, are equivalent. And when this situation happens, they are linear depending. So when you will be able, maybe it's not easy identification. What is the number? I know what is the number in this example. In another example, maybe no clear 100%. But I try. So when you will be able to take one equation and you multiply it by one number, and this new equation after the multiplication is equal, is twin brother to another equation in the system, is because these equations are depending. Okay? See, it's impossible. Better. It's the most nice scenario in which it's independent. Independent, impossible doing this. Multiplication by one number and you get another equation gets equivalent to another equation inside the system. It's dependent, linear dependent and linear independent. For example, in the equation 1, in the example 1, sorry, in the example 2, the equations are totally linear independent. And the reason to explain a little bit graphically is because in the second example, they are parallel. It's not the same line. It's obvious, right? In the second, they are oblique lines. Okay, of course, it's not the same line. This line are, this equation, sorry, are independent. When it's the same line, the equations are dependent and we have infinity many solutions. I don't finish the idea. The idea is more deep. Do you follow me? Infinity many solution, dependent or independent? I want to hear opinion in this moment. Okay, two concepts important. Infinity many solution is new. Alice will say yes, okay. Okay. However, do you understand very well the idea behind linear dependent or linear independent? How you prove that two equations are linear dependent? Let me try. I don't know. Do you see my face? In this moment, you see my face or not? Or you see only whiteboard? No? My face, no. No. My face. You see my face?
Yes, we see you.
Okay, cool. Okay, you have, suppose in general, you have a system. I promise we study complicated system in pre-calculus. You have several equations. 1 equation, 2 equation, 3 equation, 4 equation, 5 equation. Now, you discover that equation 2 and equation 3 are depending. If you multiply by one number, que no necesariamente 2 and depending the example, one equation 2 and S equal equation 3. These equations are depending and do not apport information. Actually, we have no 1, 2, 3, 4, and 5 equations. No, we have only 4 because this equation and this equation are dependent. Actually, we have 1, 2, 3, and 4 equations. This idea is clear? It's clear? Ahora, now, the complicated part to understand. Pay attention, please. When you discover that we have infinity many solutions, en intermediate algebra, you say, infinity many solutions, no problema. Pero en precálculo no. En precálculo, you need to specification more. Entonces, to specification more, you need to understand the idea of behind the free variable. Free variable. What is the free variable? Bueno, the free variable is a one variable que you declare, suppose X or Y, I don't know exactly in this example, que you declare que is all real number. For example, one possibility to express it, the answer is the problem is, you declare que X is free. Free means que X is all real number. Remember, all real number is a one-dimension line, no? From negative infinity to positive infinity. So to be free is because this variable is all real number. No limitation. However, why not? Because Y somehow depending of X. Entonces, because a Y free, entonces it's completely the XY plane. No, it's a specific one line that you take. You separate by comma because the other pair X comma Y, no? Pero no. You put X like a free and Y is 3X plus 2. How do you know 3X plus 2? Because there's the connection, is the mathematical relationship between Y and X. And you copy, and this is equivalent to say infinity many solution. There are many ways to express this. The majority of the example in Alex, they like that way. However, another more sophisticated is that the solution is expressed like using self-building notation as X comma Y such that this symbol indicates such that, I don't know if you are familiar with this mathematical symbol, such that if you put the equation that Y equals 3X plus 2, comma, and you declare that X is any real number. ¿Qué es equivalent? To say free variable. Are you clear, guys? Do you understand the notation, the interpretation of this? Because si you declare que X is free and you declare que Y is free, well, because it's all the XY plane. It's not true. It's only the point on the line. Okay, exists another possibility. Yes, exists another possibility. Suppose the famous X comma Y, the formula is Y equals 3X plus 2, no? And you, for example, you declare that the free variable is Y, then you put comma Y, and you try to express it X like a function of Y. It's super easy. It's Y minus 2 divided by 3 is X. And you copy here Y minus 2 over 3. And this solution, unbelievable but true, is equivalent 100% of this. It's the same thing expressed in different. They are equivalent. It's the same. After now, the only thing that changed is the declaration of what variable is free and what variable is not free. Guys, do you follow me or no? Remember, this is precalculus.
I'm following.
Cool. This is easy, but in the precalculus, we complementing the thing. No, it's not trivial like elementary. Okay, let's move on to the one more example 2D. Que bring me new situation. I feel that this class is smart. The majority of you are in the correct level of the mathematics. Another no. You need to realize by yourself. Okay, so now we have, let me copy it one more time. This is 3x minus 4y equal 1. This is my equation I want to call number 1. This number enclosed in the circle indicate the name of the equation, 1, 2, 3. You can write A, B, C, or name Maria, Jose, but no, normally it's 1, 2, 3, 4. And another equation is 2x plus 3y equal 12. Okay, two equations one more time and two unknown. Okay, but in this case, no coefficient C1 or -1. No. Entonces you need to apply elimination. Guys, elimination is the best. Elimination, you can apply 99% of the time. Substitution is a special method you apply sometimes when it's trivia, when the coefficient is 1. So now, what is the idea behind elimination? Elimination, you need, for example, you need same coefficient, suppose 12y and negative 12y. So you will be able to create in the system same number and opposite sign, one positive and one negative. When you add in that column, give me 0. No, 0y is equivalent to 0 because 0 times any number is 0. This is the idea behind elimination. So I propose you one strategy. There are no infinity, but there are several strategies to apply elimination. For example, I take advantage that this guy is negative and this guy is positive. That's exactly we need, opposite sign. And you multiply the equation 1 by 3. Multiplication by 3. So the multiplier they are using a 3. And why not? The equation 2 multiplied by 4. What is the idea? Well, the idea is when you multiply 3 times 4 is 12, negative 12, and when you multiply 4 times 3 is positive 12. Ready. It's ready for elimination. And you multiply, of course, you multiply whole thing, guys. You multiply 3 times 3, is 9, and you create a new system, minus 3 times 4 is negative 12. And 3 times 1 is 3. And this equation is the same equation of the original number 1 because they are linear dependent. It's the same line. When you take one equation, keep in mind this, and you multiply by one number, positive or negative, I don't care, or fractional decimal, the new equation is equivalent 100% to the original. Okay? However, it's better because I guarantee negative 12. Suppose you multiply by 4, and 4 times 2 is 8x. 4 times 2 is 8. 4 times 3 is 12, but a positive 12. Wow, good. And 4 times 12 is 48. And this is my equation 2. And this system, guys, maybe you believe, because some teachers don't explain very well, or you don't understand very well, it's different. No, it's the same system, it's the same line, it's the same solution. But now you adding, who you adding? You adding the equation 1 plus equation 2. But you adding by column, that column. Let me use this marker, it's good. That column is the column of the x. That column is the column of the y. And that column is the column for the right-hand side number. It's just number. And you adding, this is 17. 9 plus 8, 17. Cancel out, 0, nothing. Equal 51. Wow, now it's pretty easy. You divide by 17 both sides. X equal 3. Okay, I need to find the y value. To find the y value, then you take either equation. I don't know exactly what I choose. Maybe the first or the second. I choose the second. I don't know why, because I like. Maybe. No, the first one. 3 times 3. So you replace. I know x is 3. You take the equation 1. For example, so you take the second equation, the answer is the same. This is the beauty of the mathematics. Okay, so 3 times 3, you replace x for 3, gets the value, minus for y equal 1. Okay, so 3 times 3 is 9. And minus 4y equal 1 minus 9, is negative 8. Divided by negative 4 both sides, y is 2. Wow, this is the solution. Is the order pair 3, 2. It's exactly the thing I try to illustrate in this graphic. No? Okay, and 2D is super easy because 2D, any problem in 2D, suppose you don't remember very well the algebra, you put in decimals and you find a solution. The only disadvantage is when it's graphic, you lose information, see a fraction or a decimal or it's irrational. But I try to explain no graphically is to interpret something. I want to explain geometrically, no? Geometrically and algebraically is better, right? Algebraically is better. Okay. So far, everyone follow me? Sure?
Yes. Yes.
Okay. All right, let's move to the complicated world of the 3 dimension. 3 dimension now. 3 dimension. 3D. Okay. This is happening traditional in mathematics. When you increasing the dimension of the our problem, it's more complicated because we have more options, more variant. No? Let's suppose in 3D we have 3 variables, 3 equations, 3 unknown, maybe. Suppose one equation classical in 3D. X minus 3y plus 3z equal negative 4. Oh, this is my first equation. I suppose here we have 2 more. So for the equation is, professor, the number of equations necessary is equal to the number of no. The answer is no. But I promise, guys, I see every option. So when you finish pre-calculus, you are strong to destroy any system that you can find in calculus. Okay, but the most important I want to discuss it now is what is the geometric representation for this equation 1 I copy here? Well, no idea. I see one equation, but we have 3 variables. So we have 3 variables. 3 variables. Because it's x, y, and z, no? But you have only one equation. And to say now, when you're subtracting the number of variables, this is classical, minus the number of equations, you get the degree of freedom of our problem, no? And what means degree of freedom? So 3 minus 1 is 2, no? This does mean that the object that geometrically represent this equation have dimension 2. So what is the dimension 2? I don't understand very well. Well, dimension 0, so degree of freedom 0, is a point. Because point have no length, width, height. Degree of freedom 1 is the classical line. Okay, dimension 1. It's a geometric object dimension 1. And degree of freedom 2 is a plane, because the plane have 2 dimensions. We have dimension in this direction, dimension in this direction, dimension in this direction. 2 dimensions. Okay, degree of freedom represent, the geometric interpretation of this. Therefore, the equation that we're solving now in 3 dimensions represent the plane. Completely different situation can happen in the other problem that we are working in 2 dimensions. So one classical equation in 2D is x plus 3y equal 4. Oh, in this case we have 2 variables minus only one equation. 2 minus 1 is 1, degree of freedom 1 represents the line. That is the reason that we are doing line. Pero en 3D no. En 3D es a plane. Ajá. Entonces now, we, in few minutes or seconds, you see now a system and we face solution of the system. I want to explain the algebraic procedure que es more complicated in two dimension. In two dimension. But you need to be aware for different situations. For example, let me focus in this picture. In this picture, we have three planes. For example, the orange color represents the equation 1. It's a plane. I suppose que es blue-green, something. This is equation 2. And the blue, hard blue, is equation 3. Wow, and you see these three equations intersecting in one common point here, is the solution. And you have solution is the triple order x, y, z. So the goal, our goal, is find the value of this point. I don't know exactly. I create one hypothetical number, 5, 3, 2. So x is 5, y is 3, and z is. This is the idea. But we have another possibility. For example, in the figure number B, the intersecting another point. It's a line. Entonces es obvio que en this scenario we have infinity, many solutions, right? Because any point on this line is solution. Let me use it in different color. Let me use in red color. Solution, 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 solution. But this is no solution. This is not. Of course, this is not. It's only common in between this line. But remember, when you express it, the answer in precalculus, you need to declare free variable. And in this case, the free variable is 1. Because the solution mathematical object is a line. And line is the geometric object that have dimension 1. And so when you finish algebraically, you have degree of freedom 1. In this case, no. In this case, degree of freedom 0, no? Do you understand this idea or no? Okay. Repetition again. When you have unique solution, only one solution, nice, no problem, no free variable. When you have a degree of freedom 1 or degree of freedom 2, I don't know. Let me see. Yeah, you have infinity many solutions, and you need to declare formally when you finish the final answer this free variable and the relationship between the variable. In this moment, I suppose you have a question. Yes or no? No? Do you understand the idea? The basic idea? Because I have more example, and you help me to understand this. For example, let's focus on this figure. Okay. I want your. Hey, what the hell? Yeah, don't change that. The view, get view. It's much better. I see every face. Do you follow me? Yes or no? Yes or no? Okay, wait. Let's do a competition now. Competition. You help me to understand. In each picture, see, we have one solution, no solution, que es equivalent to say 0 solution or infinity many solution. And when you have infinity many solution, how many free variable we need to declare? Depende si es a line, es one free variable. Si es a plane, entonces 2, ¿no? Basically. Si es multi-dimension, entonces the question of flying, the professor says multi-dimension, more than 3 dimensions, because you have system 4 equations, 4 no. Well. System more dimension is impossible, represent geometrically. However, it's perfect possible, represent algebraically. This is the central idea for the chapter. So we solve any equation with any order. Because in the real life work problem, you have 20 equations and 20 or not. And you need to know how you solve it. Okay, okay, no. Let's move again to the whiteboard. For example, what do you think about that figure? The figure number 1. Okay, remember, only we have 3 possibilities. No solution, 1 solution, or infinity many solutions. Participation, come on.
No solution.
No solution, very well. No solution. Why? Could you explain why?
Because they're parallel to each other.
Exactly. And we have no common point in between the plane. Remember, any plane, red, yellow, and green, represent 3 equations. And these equations have no common point. Therefore, no solution. Correct. Very well. Let's move into example 2. What do you think of example 2? We have solution, 1 solution, infinity many solution, or no solution.
1 solution.
1 solution. Everyone is agree with him? Everyone? Come on, you can have discrepancy, no? The idea is discussing this idea together. Come on, repeat loudly and clear.
Infinitely solutions.
Absolutely, infinity many solutions. Why, mister? Because, look at that. Because you see the common part in between is this line. Yes or no? Okay, entonces now, si you have a point, yes, it's 1 solution. In this case, you have infinity solution. To be solution is possible when you have common part. O sea, when the 3 plane, not 2, touch it. Because we have, of course, we have infinity many solutions. Okay. But remember, in precalculus is not too much this information. How many free variables we have to declare to represent the solution of this? How many free variables in this particular example? How many free variables? How many free variables? 1 free variable, 2 free variable, 3 free variable. 3 free variable. No. Okay. To understand this, okay, do you see, using your eyes, no mathematical, que the solution represent a line? Yes or no? A line. Yeah? Yes or no? Say something. Do you see? Okay, yes. Kiana is yes. What is the degree of freedom, Kiana, of the line? What is the degree of freedom? So a line, represent like a Alison. Yes. What is the degree of freedom of the one line? No, es 1. Sin ahí, it's only 1. Degree of freedom is 1. O sea, line represent object in 1 dimension. O sea, suppose que es, suppose que es a road and you travel forward or reverse. Pero you cannot move it upward and downward. No, in one direction. It's 1 dimension object. Therefore, the number of degree of freedom is 1. So when you solving this system that I want to explain in a few minutes, you need to declare 1 free variable. Okay? What about number 3? What do you think of number 3? Thinking, please. Don't say something without think. We have solution, no solution, infinity many solution. Come on. And for today, I need answer now. What's going on? A ver. Solution. Alison is solution. Everyone is agree with the Alison? Solution. Alison is a solution. Pero infinity many or only 1? Remember, 2 solutions. Jonathan is 2 solutions. Everyone's wrong. Everyone is wrong. Everyone is two solution, Jonathan. No, everyone is wrong. This is a classical example, no solution again. No solution again. Why? I want to explain why. Pay attention.
Because the three don't intersect at any point, only two of them at multiple points.
Entonces, what do you think? ¿Es infinity many solution or no solution?
No solution because the three don't intersect.
In between who?
Between all three of them,
Exactly. Okay. Look at that. I agree 100% that this line is common line between the yellow and the red. Yes or no? However, this line is the common line between yellow and green. But there are no common point in between the three planes. So you need to find a common point between three planes. So one common point between que belong to the yellow, to the red, and to the green, both together. No solution. Do you see? Do you see? Come on. Opinion. I need opinion. Do you see or no? O sea, the solution is one point or line, whatever, but it's common. For example, in the example 2, we have solution because this line belong to the red, to the yellow, and to the whatever.
Does number 4 not have a solution?
You follow me. I cannot follow you. You obey my command. Number 3 and number 2. Number 4, what do you think about number 4? Come on.
No solution.
Exactly. By the same reason. There are no common point between green, red, and yellow. No common point. No. And what do you think about number 5?
One solution.
Exactly. One solution is the intersection. One solution, degree of freedom 0, no free variable. 1 point, I don't know exactly the point, I don't know, 5,1, negative 2. Suppose, hypothetically. Do you understand very well the idea, or we need to see more example? Or clear? Or let's go directly to the example algebraically. I suppose you have roughly idea, no? Yes or no? This is at least, Shane, at least the first approach to this. Let's move into one example. Okay, I want to copy you again. No idea. This is we solving our first system in 3D. Is x minus 3y plus 3z equal negative 4. And this is my equation that I want to call number 1. 2x plus 3y minus z equal 15. Equation 2. And 4x minus 3y minus z equal 19. Equation 3. And this is the system que contain 3 equations and 3 unknown. If these equations are linear independent, well, degree of freedom is equal the number of variable minus number of equation. The number of variable is 3, number of equation is 3. Well, I suppose que es 3 because the supposition is que they are linear independent. Repetition because it's depending and you don't see, sorry, you are in big trouble. Entonces es 0 degree of freedom. We have one solution, que es this solution. Okay, I don't know the value, but I want to find in a few minutes. And this you have unique solution. Okay. This is a little bit long process. So I recommend que don't do in crazy way. No. You need to organize your work in the way I want to explain now. you pick two equations. So you pair two equations. For example, in my paper, I pair equation 1 and equation 2. But why, Professor, I pick 1 and 2? Because I am a smart guy. I realize that in the equation 1 and equation 2 we have minus 3y and plus 3y. Wow! Entonces es ready for elimination. It's ready for elimination. Do you see that? Yeah, Kiana. Entonces, one equation plus two equations. Look. Remember, guys, I put in standard. In standard, I put in alphabetic order. The X column, the Y column, the Z column. Maybe in one problem, it's not totally organized, but you organize to solve the system algebraically in standard. So one column of the X, one column of the Y, one column of the Z, and one column can represent the right-hand side without variable. So you're adding S3X because 1 plus 2 is 3. This is say goodbye, cancel out, plus 2Z equal 11, no? Because 15 minus 4 is 11. I call equation 4. And this equation 4, que contains two variables, is a line que connecting maybe, I don't know exactly in this moment, si es the plain green, suppose que the plain green is equation 1, and the plain red is equation 2. This is equation for this one. Okay. I feel no, this is just the beginning. Now I pair two new equations, okay, using the same, and this is the most important thing I want to say today. You pair two equations, but what is the intention? The intention is eliminate the same variable. If you in the first couple you eliminate the y variable, mandatory in the second you have to eliminate the same. You eliminate another, you are in big trouble. So I copy in my paper, I copy again equation 2 and equation 3. Okay, is 4x and minus 3y minus z equal 19. Equation 3. And you are doing exactly the same idea. Addition 2 plus 3 by column. The column of the x is 6. The column of the y, say goodbye. The column of the z is minus 2z. And this is 34. And 14 carry the 1 plus 1 is 2 plus 1 is 3. And this is my equation 5. Okay, this represents another line that's intersecting in two planes. Now you put together. This is the most important moment. And you put together. You put together who? You put together equation. Let me copy here because I have a picture here. It maybe interfere a little bit. All right, let me see. Okay, I copy. I copy the system. 3x plus 2z. I am copying the equation 4 again. I don't know why. To make clear, I copy the equation 5. Wow! And this is a new system. Okay, we're solving very similar to the thing we are doing before. It's two equations and two unknown. Wow! And also it's ready for elimination because by coincidence, not always happen this. I try to find the super fantastic easy problem to make the first example. So I see you adding 4 plus 4, equation 4 plus equation 5 by column. It's a 9. The z is canceled, 0 again, and we have 45. Okay, it's 45. Divided by 9 both sides. X equals 5. Bang! I feel no, I need to find y and z. I need to find the triple order, x, y, z. Let me delete this picture. Wow. Okay, cool. Now, to continue, I have in my hand X value. I need to find, for example, Y and Z. No, but no in that order. Because you substitution this phi in the original equation that contains 3 variables. No, you have 2 more variables. So my recommendation is substitution in 4 or in 5. I suppose that I substitution in 4. So I pick 4 again. Look at that. 3x plus 2z equal 11. You replace 5. So 3 times 5 plus 2z equal 11. This is 15 plus 2z equal 11. 2z is equal 11 minus 15. 2z is equal minus 4 divided by 2. C is negative 2. Wow, I almost finished. Entonces, in order to finish, I come back to the original equation that contains 3 variables. Cool. And now I pick, for example, I pick the first one. Pero not necessarily you pick either. I pick the first one because I consider it as easy. Entonces, I substitution, no x anymore. No. X is 5. Minus 3y. No idea who is y. Plus 3 times negative 2 should be equal negative 4. Okay, this is negative 2, no? I make a weird 2. Negative 2. A multiplication. 5 minus 3y minus 6 equal minus 4. Entonces positive 5 and negative 6 and negative 1. Minus 3y minus 1 equal negative 4. Wow, too many negatives in this equation. Okay, if you want, you change the negative to positive, then you copy 3y plus 1 equal 4. No, the thing that I did was multiplication by negative 1, and that's it. The 3y is equal 4 minus 1 is 3 divided by 3 divided by 3 divided by 3. Y alone is equal 1. So how you write the final answer? Final answer is the triple order x, y, z that I discover in this specific problem 5, 1, negative 2. Bang! In the story. This is the final answer. But the thing is that these equations are completely independent, linear independent. These represent 3 planes in the rectangular coordinate system. Exactly, I showed you at the beginning. Look. So I'm using a special software, but no, don't worry for the 3 dimension. If you want to learn, this is completely out the game. This is calculus 3. Okay, and 3D, graphic in 3D is geometry in 3D is calculus 2. The student can need to take that. Maybe you see with me. Clear? Solution or no? Aha. Let's move into another example. Jose Cabrera. Jose, I want to complicate a little bit more. Look. Let me erase this. Erase everything. What's going on? No, it's okay. Suppose this example. No, yeah, this example. Okay. I anticipate something. Okay, this is the example. I suppose it's example 6, no, for today, and this is the second example in 3D. Okay, what do you think? looking the graph. So we have three equations again. Three unknown, x, y, z. Okay, by the way, I want to copy now. Is minus x plus 6y minus 3z. You need to be aware that this equation represents a plane. It's not important now what plane, is it green or blue or red. We have another equation that is x minus 2y plus 2z equal 3, equation 2. And another equation that is 3x plus 2y plus 4z equal minus 6. Equation 3, equation 3 unknown. This is my linear system. Okay, and look at the picture. What do you think? We have solution, no solution, or infinity many solutions? Remember, we have only three possibilities. Unique solution, only 1 point. Another solution is no solution, never intersecting. And another possibility is infinity many solution, that is infinity many solution that you need to declare free below. Okay. Look in the picture. What do you think? Do you understand very well the situation or no? Wow.
Infinite many solutions.
Another opinion. Another opinion. Okay, okay. The first question that you need to ask by yourself is solution. Yes or no? And the answer is yes. We have two possibilities. Unique or infinity many solution. The possibility is no solution. What is the path that you consider correct? Solution, yes or no? Yes or no? No, yes. Totally lost? You don't understand very well this? No? You see very well the figure? My question, let me reformulate my question. Do you see one common point between, que belong, green and red and blue? They are common point? No. They are common point between blue and red here, right? We have another common point between here, between green and blue. But we have no common point in between both. Every one, no common point. Do you see or no? Yes or no? Hey, say something.
Yes.
Yes. Entonces, what is the conclusion? No solution. That's solution. No. The answer yes is no. It's no solution. Do you see geometrically? Yes or no? Come on, guys. Yes or no? Say something. Okay, Alison. Okay, now we see Alison algebraically. Okay, you have not that figure. I did that figure because I put in the specific sophisticated software can create the graph. Okay, let's do it. Algebraically. Let's focus this. Remember, you split the paper in two parts. I want to see in the test and the reading test like that. Split the paper. And you copy, you pair two equations. For example, I don't know, there are no one way to do. There are no infinity, but there are several ways. I copy the equation 1. I copy the equation 1. Yeah, I copy the equation 2. Bueno, what is the reason que I select this? Bueno, the reason is because I see, using my eyes, at least in that part, positive x and negative x are ready for elimination. When you adding them, equation 1 plus equation 2 by a column, this is cancel. This is 4y positive. This is minus z because minus 3 plus 2 is negative 1 equal negative 5. And this is my equation 4. Everyone follow me? Everyone follow me? Okay.
Yes, yes.
There you have another possibility, 1 and 3 or 2 and 3. In my paper, I select 2 and 3. Look at that, interesting. Now, crucial moment. I copy 2 again. Now I copy 3, okay, 3x plus 2y plus 4c equal minus 6. This is equation 3. Let me fix it a little bit. This 3x. And you see, bueno, professor. Entonces I apply elimination one more time, and because minus 2y and positive 2y is ready for elimination. No! Because you decide that you in the first couple, you eliminate x, and in the second couple, you have to eliminate the same value. So you are doing this, you never get the answer. Okay? So I need to apply elimination, but using again the x variable. It's easy because the only thing that I should do is multiplication this equation by negative 3. By negative 3. Guys, I like that way because that way indicate me in the test what is the multiplier that you're using to create this idea. So you copy in either way, but I like to copy this. Negative 3 times x is minus 3x. Multiplication by 2 es obvio que es positive 2y. No, positive no. Es 6. 6. 3 times 2 is 6. And negative times negative is positive. And multiplication by this, again, is 6, but it's negative. Negative 6z equal negative 9 because negative 3 times positive 3 is negative 9. And this is my equation number 2 again, equivalent, nice. This is the same, no too new, no, it's the same. They are to the effect of the system of equations as linear dependent. Now ready to add in 2 plus 3 by column. This is 0, that was the intention. This is 8y, and this is 2, minus 2, because 4 positive minus 6 is 2. Equal, this is negative 15. This is equation 5. Now finally, put together 4 and 5. 4 and 5 together. 4 and 5 together. 4 and 5 together. Okay. I copy. I like to copy. I like to copy in any way here, down. AY minus 2Z equal negative 15. This is my equation 5. And we focus it now in the solution 1, super easy, elementary. 2 equation and 2 unknown. Exactly we are doing at the beginning. Well, no idea. However, I propose you, for example, multiplication equation 4 by, let me erase this, by negative 2, no? Why? What's the reason? Because negative 2 times negative 1 is positive 2. When you multiply the entire equation number 4 by negative 2, we have now negative AY, multiplication this and this, and negative no positive, negative times negative positive Z equal, this is positive 10. This is my new equation 4 equivalent 100% to the original. Now 4 plus 5, Wow, something weird happened. This is cancel, this is cancel, this is 0. And this is 10. No, -5. This is completely false statement. So what is the interpretation of this guy? I try working, but I get impossible solving any variable, and you get completely false statement. What mean that? Huh? What mean that? No solution. Very well. No solution. And you see more clear now geometrically. Let me come back again to the picture without algebra. Of course, to get that picture, we need sophisticated software. It's available online, but it's okay. This is another challenge. Now you see it's no solution, no solution, no solution. This system have no solution. There are no common point in between red plane, blue plane, and green plane. Let me try another. Let me see if this one. Yeah, that one. So let me try to delete that. It's not important now for me. It's not that. Let me try to find one place. Too many places. Okay, erase. I don't want to erase everyone because I have another slider. Okay, let me make the soup. The soup. The soup. The soup. Oof. Erase. Okay, we have that problem. Is number 7, no? For today, no? Number 7. I want to copy again to see more clear. Oh, look at that. This is the system 2x. Oh no. 2x. 2x. Cool. Plus y equal -3. This is my equation 1. Guys, sometimes happen, not always, but seldom. Sometimes happen that in one equation, one variable is missing. In this case, the equation 1 is missing z. Okay. However, in the equation 2 is missing x. So now, let me try to organize an elegant way. Elegant way is, look. Well, okay. I put a little bit of space, x, y, z, and negative. This is my equation 1. And my equation 2 is no x, 2y, 16z equal -10. Okay. Let me try to put a little sign a little bit to the right. This is equation 2. Do you see that the x is missing and the second equation missing and the c is missing in this equation? No always happen, but sometimes happen, and you need to be aware for that situation. Entonces now in the last equation, nothing is missing. Eight. Okay, this is my system, que sometimes it's incomplete, but in this case, yes. Look at the picture. What do you think? Solution or no solution? Solution or no solution? No. Or no solution. Opinion. I want to hear opinion. Solution. You are right. Solution. Solution. Chain. Only one or infinity many?
Infinite.
Yeah, you are right. Infinity many. But remember, we are taking precalculus. In precalculus, we need more information. We need how many free variables we need to declare. How many free variables? How many free variables? we need to declare. Huh? This is a part that you don't understand very well, no?
Is it 3? Is it 3?
Is it what?
3. 3.
No. Hello, we have 3 variables. Entonces now, the free variable is always less than 3. O es 1 o es 2. Pero no 3. Bueno, 3, no, 3 is impossible. Okay. Guys, this is not science fiction. This is natural mathematics. But the problem is, the teacher in the high school don't explain this. I don't know why. So look, when you have one solution unique, it's obvious que the free variable is 0. We have no free variable. And the reason is clear because we determine 1 point, exactly the same we are doing before. However, when there's infinity many solution, bueno, entonces the free variable is different to the 0. Exists the free variable. The problem is how many? How many? So one possibility is one free variable or 2 free variable. Oh, depending on the problem.
Sorry, what is the free variable?
I need to explain again.
I don't think I'm understanding what it is.
Yeah, I know that you don't understand, but I explain. Okay, I want to repeat for you, so pay attention. Okay, when you have infinity many solution, in this case, it's obvious it's infinity many solution because I see that we have solution. We have 3 equations, the equation 1, equation 2, and equation 3. Suppose the equation 1 is the blue plane. The equation 2 is the green plane. And the equation 3 is the red plane. And you see that exists a common point in between this plane, que es this line. Yes or no? Any point on this line is solution. This point, no. 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 But this point, yes. This point, yes. This point, yes. Entonces now, when you write algebraically the solution, you need to specification free variable. And the free variable is 1 because this common part in between the plane is a line. And the line, I repeat 3,000 times, que es the geometric object dimension 1, because it's a line that represents a rod and you can travel only in the positive direction or in the negative direction. Now it's clear or no? It's clear or no? No. What part no?
So the point.
Come on, quickly.
So by free variable, you mean like where we know it is?
No. Look, I want to repeat one more time, but a different way. When you determine that we have infinity many solutions, it's because, yes, we have solution. So the plane touch it. They are common point. That part is good for you? Do you see that in between blue, green, and red plane?
Yeah, I understand that all 3 intersect at more than 1 point. Yeah.
Yeah. Entonces now, but the problem is that this touch not in only 1 point. You touch an infinity point. Look, this point, but let me erase to see more clear. Erase. This is the line. This is a line. Do you see a line? You see black color. So any point on this line is solution for the system. Yes or no? Do you follow me? Yes or no? No?
Sorry, my mic is muted. Yes, I'm following.
Okay. Then when this infinity many solution and dimension 1, degree of freedom 1, because it's a line, solution is a line, you need to define 1 free variable, only 1 free variable. I don't know exactly si es x, si es Y o es Z. Let's see after algebraic. Now, I'll try to discussing now the geometry idea. Geometry idea is this system que have in this figure have solution. Yes, 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 but not only once, you know, infinity many solution. And the intersection between this plane is a line, and the line contain infinity point, but in only one direction. Therefore, we have only one free variable. Clear?
So that direction is the free variable?
Exactly, the degree of freedom. The degree of freedom. So do you understand que one line?
Yeah,
one
I understand that the one line is where all the, you know.
Degree of freedom one? Do you understand this idea?
Okay. So if they all.
Let me finish. One plane. This is the plane. This is the line. Degree of freedom is 2. And 1 point, degree of freedom 0. And that's it. It's the only object in 3D at least. Degree of freedom 1, line. And this number represents the free variable. Okay, I
get it. I get it.
You got it. Okay, cool. Okay, now let me try to I finish this example. Oh, no. Okay. Okay, as always, you split the paper into parts. Guys, to learn very well this, you have to do the homework. Okay, you fail the test is because you don't do the homework. And the homework you have my support, 100%. You email me. I have some students that are found with me, ask me, Professor, could you help me in one specific question? I explain. But this is the study before the test. The test day is too long. It's too late. Okay, so now I take the question 1, which is 2x plus y. Say I want to organize, I put 0c. Then no problem, because this is same thing, the upper. Equal minus 3. And this is my equation 1. I pair with the equation 2. And the equation 2 have no x. 2y 16c equal minus 10. Equation 2. Wow, what should I do? No idea. Well, I suppose one good idea is multiplication that equation by -2. So the multiplier, okay, I select as -2. And when you multiply the equation, the entire equation, number 1 by -2, we have -4, I copy down, either way, minus 2y plus 0c, because -2 times 0 is 0, equal -6. And this is my new equation 1. If you want, you forgot that. No, I do not recommend, because maybe we're using in the future. But no.
Wouldn't it be +6?
What is your strategy? I need to understand your strategy. This is not total aleatory number. So my intention was, when you multiply by -2, this guy, to say you create -2 and +2 ready for elimination. And what is your strategy? No strategy. Entonces no good. You need to plan in one strategy.
Yeah,
okay.
But wouldn't it be +6 instead of -6?
Where? Oh, no. Yeah, it's +6. Yeah, you're right. Because it's -2. Yeah, you're right. You are right. Thank you. +6. Okay. Ready by column. The column of the x, the column of the y, the column of the z, and the column. This is mechanical. 1 plus 2. It's -4. This is say goodbye. 0. 16z equal -4. And this is my equation number 4. Everyone follow me? Everyone follow me? And the other side, not yet?
I'm following.
Okay, good. I take now the equation 2. I don't remember exactly why. 0x plus 2y plus 16z equal minus 10. Equation 2. And equation 3 is the last one. No? It's minus 7x minus 3y plus 4c equal 8. Equation 2. Okay. The most important, guy, if you eliminate y and this, you have to eliminate y here. This is super important detail. So what is my strategy? Well, my strategy is maybe multiplication, the equation 2 by positive 3 maybe, multiplication, the equation 3 by positive 2. Why I create this strategy? Because 3 times 2 is 6 and 2 times minus 3 is also negative 6, and to be ready for elimination. Okay. There are another combination. Of course, there are another combination. And any combination that you are doing well, you get the same answer. This is the beauty. Now, let's do it in the multiplication. Multiplication 3 times 0 is 0x. I am doing the multiplication, this times this, times this, and times this, and times this. Plus 6y plus 48z, that was the multiplication 3 times 16, equal minus 30. It's equation 2 is equivalent 100%, totally depending, it's the same plane. Now let's do multiplication by 2, get negative 14 x minus 6y plus 8c equals 16. This is my equation 3. Okay, one more time, equation 2 plus equation 3 by column, of course. The column of the x, the column of the y, the column of the c, and the right hand side. This is the organization. So it's negative 14 because it's 0. This is say goodbye, cancel out. That was my strategy. Cool. Plus 56z equal negative 14 gets minus 30 plus 16. And this is my equation 5. And this is my equation 5. And you put 5 and 4 together, but surprise. Surprise because I forgot, because I am too fast, doing too fast, I forgot. One simplification, okay, always we can do that. For example, in the equation 4, I see that any coefficient is 4, 16, and 4. So any coefficient is divisible by 4. If you want to change the sign also, why not? You divide by negative 4 the entire equation. This is easy because simplification. So working with the small number is better, no? So it's x minus 4z, because 16 divided by negative 4 is negative 4, equal negative 1. So this is equation 4, exactly the same, but it's easier. The coefficient is 1, negative 4, and negative 1. Negative 1 or positive 1? Positive 1. Positive 1. Likewise, in the equation 5, we can do simplification. You can divide by negative 14. Suppose, guys, you don't realize this, no problem. After you can see. You divide by negative 14, you get x, and this is 56 divided by negative 14 is 4. But positive divided by negative is negative 4c. Is equal 1. Is equal 1. Yeah, and it's equation 5. Wow, look at that. Do you see what is the problem? I copy equation 4 and equation 5. What do you expect to happen? What do you expect to happen? See, the equation is the same. This is logical or no? According to the picture that we see before. That picture. That picture is the three plane, three equation, green, blue, and red. And I discover that we have infinity many solution. I discover that we have one line here that is common. So you have solution, yes, but infinity many solution. Do you see? And the clue que es infinity many solution is because it's the same line. Do you see? Similar idea, but of course more simplification in 2 dimensions to get 4 equal 4. It's identity. This is true. Indicate it's infinity many solution, but I don't know exactly. Okay. Now I need to express the final answer. How you express the final answer? Okay, let's do in that part for the next lecture. Because it's long, I want to next time I want to see again that part, discussing one conceptual part, and after we don't finish. In conclusion, okay, we don't finish. Okay, guys, any try to see your grade in Canvas. So you go to the website of the Miami-Dade College, go to the Canvas, and you find your class, and you see I posted your grade in the Alex, and I posted your grade in a reading test. Some students que send me the test with the answer only and not the word, I send email to say que I need to resend me with the answer. No, it's okay. It's no problem. It's the first time I understand. And the second time I don't understand, but in the first time, yes, I understand. No problem. Okay, you say, is here Mr. Otero? Mr. Otero is here?
Yeah, I'm here.
Yeah, okay. I go to the restroom. Guys, bye-bye. See you next time, Monday. Stay here with me. Benjamin. Michael. Okay, cool. I'll be right back. Okay, I am back. Okay, I want to see your face, Richard. Okay, cool. I understand. I understand because I don't know. This is the first time it happened. Your name is in my roster. However, when I copy the email address, it's missing your email address. Now I include it. Okay. So now the thing I want to discuss with you is how we solve the problem. Okay, so that you don't do that. the Alex. Okay, let me explain in detail. I don't know if you interchange with another students. Richard, you speak Spanish or no?
Sí, yo hablo español.
Yep, pero es better in Spanish or in English it's better?
Lo entiendo lo mismo, pero no lo puedo hablar tan bueno. ¿Entiendes?
No, so let's try in English.
Okay.
Okay, look. Are you aware que the subject contains two parts, no? One part is so basically we have 8 tests. 4 online and 4 online. Okay, and the online is in Alex, que es the platform. But that's easy. So you can sign in today without money because it's free for 2 weeks. After you need to pay. I don't know the price, pero in the syllabus you can find the class code. Do you see? Do you receive my syllabus?
Yeah, I already signed up for
Cool.
Alex and everything.
Ah, you did that? Wow. Okay, so now my question is, no, relax. Everything gonna be okay for you. My question is, how long you need to extending for doing? We have 3 homework and 1 test, and the homework is important for 2 reasons. Reason number 1, you study doing the homework, you study for the test. Reason number 2, so you finish the 3 homework with a score greater than 80%, you have reward 10 extra points in the test. You get, for example, 90 points plus 10, 100. Do you understand?
Yes.
It's important. And the homework, anytime you are doing and you are stuck in one problem, you can email me with a screenshot of the problem because you need to specification what problem, because you say, Professor, question 20. Your question 20 is different to my question 20 to different to another student. It's totally different. So you make a screenshot, you send me, I solve it in 5 seconds, bam, I send to you the solution. I suppose one small explanation, and you understand because the mathematical language is universal. It's universal. Okay? So my question is, how long we need to get extending for you finish successfully the first test? June, no? I suppose it's June something, no?
For what?
So I can create extension for you.
Yeah.
My question is, what date? A specification.
How long does it usually take for the homework?
June what?
How long does it take for the homework to be completed usually?
It's up to you. No. How long? You understand that you are late. I suppose you are working. You are working in the chapter 2. It's already. So the rest of the student is working in the chapter 2. But in this moment, you need to do extra effort because you're working in the chapter 1 and the chapter 2, no? Entonces now, my question is, I can set up the extension for this. June 16 is okay for you?
Yeah.
No, don't say yeah. You see the calendar, please, in your smartphone, and say if you agree or disagree. This is the deal. So June 16 is.
It's a Friday.
It's a Friday. No, you have enough. Okay, June 16. June 16, I suppose, is the due date for the second chapter. So you finish first and second. Okay? Cool. Second, the test on paper. Do you receive or no?
Did you send it through email?
Yeah, through email.
Yeah, I think I received that. I was able to see it.
Okay, so solve it and send me back as soon as possible.
Okay.
Cool. Done.
Professor.
Thank you so much.